you guys. So last week we talked about ratios, rates, and proportions. We talked about ratios and rates being things that compare, ways to write two things and compare them. We talked about proportions being two equations that are equal to each other, meaning that this right equation is the same as the left equation. So 1/2 is the same as something like 2/4 because you can reduce it down or you can cross multiply. So we talk about our different proportions and our ratios and our rates, they all tie in together. So this week we're going to talk about proportions, but we're going to look at them in a graph and a table and an equation. So we're going to look at the different ways that we can write them. You're going to hear me say the word constant of proportionality. Constant of proportionality is a fancy way of saying unit rate. So that is something that we are going to touch upon, and we are going to make sure that we write it down here in a little bit. But there are things that I want to make sure that you understand. So last year in 6th grade, you guys talked about y being your dependent and x being your independent variables. So these are two different variables that we use. You use x and y when you're writing a table or a graph. Remember, we use x, comma, y. So we have x being our independent variable and y being our dependent variable. What we do when we state this is we make sure that we remember that the y depends on the x. So our y is going to be whatever is happening due to your x. Our y always depends on that x variable. So when we work with our graphs and our table, we use a lot of x and y, which is where this comes in handy for our independent and dependent. So remember, on our graph, on our chart, our y's go up and down and our x's go left and right. And right here is that 0, 0, or also known as the origin. The origin is at 0, 0, where both lines come together. Whenever we write our different ratios and rates, we put one thing on top of the other. What we didn't discuss earlier is that's always labeled y over x. It's always going to be our dependent on top of our independent. So when we look at this, it's always going to be y over x. So I stated earlier that you're going to hear me say constant of proportionality. So I'm going to go ahead and write that here. Constant of proportion. I'm going to run out of space. Proportionality. And constant of proportionality is the same as, also known as, aka, also known as unit rate. And unit rate is where we have a denominator of 1. So when we want our constant of proportionality, when we want our unit rate, our denominator of 1, that means our x is equal to 1. So on your chart and on your table and on your graph, you're trying to figure out where that x is 1 and what your y is going to be at that point. So you're going to look for the dot where the y or the x is equal to 1 for your constant of proportionality. When we use y over x, and we're trying to use our proportions here, we're looking for proportional relationships. And proportional relationships are where they're both going to be equal. The x and y change by the same amount for all ratios and rates. Our x and y don't change by the same amount, but to go from each new ratio, each new rate is going to change by the same amount. So when we talk about proportional relationships, we're talking about our constant of proportionality, we're talking about our unit rate, we're trying to get a denominator of 1. And all this is going to make sense when you see some examples. So when we're talking about our constant of proportionality, our proportional relationships, when we're trying to figure out whether or not a graph or table is going to be proportional, three different ways that we write it. So there's an equation way. And the equation, in order for it to be proportional, in order for it to have a constant of proportionality and to be proportional, we write it as y equals kx, where k stands for the constant. So that's what our constant of proportionality is. Whatever is in the k spot is going to be our constant of proportionality. So you may see something like y equals 0.5x, or you may see something like y equals negative 5x, or you may see something like y equals 1/2x. However, ones that are not going to be proportional are if I give you y equals 0.5x plus 5, or y equals 3x squared, because we can't have a squared and we can't have anything added or subtracted. So it's going to be written as y equals some number in x. The other way to look at it is using a graph. Using a graph. And our graph, sometimes those go down, but most of the time you just see that one little corner. It has to go through the origin, which is right here, and it has to be straight. These two things have to occur in order to make our graph proportional. So it has to go through the center and it has to go straight. So for not a graph that's going to work is if I give you something that doesn't go through the center or through that origin, or if it is squiggly. And we're going to work on some examples that will make this all seem a little bit easier if you're not quite understanding our notes here. The last way is a table. To see if it's proportional for a table, all of our different tables, all of our different charts have to be the same. So if I give you something like x and y, if I give you something like 2, 3, 7, 9 for my x's, and my y is 4, 6, 14, and we'll do 18. So remember, it's always y over x. So y divided by x, that line means divide. So 4 divided by 2 gives me 2. 6 divided by 3 gives me 2. 14 divided by 7 gives me 2. 18 divided by 9 gives me 2. 2. So all these are the same, which means that this is proportional. One that would not be proportional is if I gave you something like, let's see here. I give you something like 2 fifths, and then if I give you 3, 6, and 7 fourteenths. Right here, 5 into 2, so top number inside, bottom number outside. 5 can go into 2. Oh, yeah, those are points. And sorry, 0.4 times. Sorry, these are 0.5. Sorry, you guys. They're all 0.5, so they're all going to be equal. So 5 goes into 2, 0.4 times. But 6 goes into 3, 0.5 times. These two numbers are not the same, so this is not proportional because they are not equal. Sorry, you guys. Just change that. So, in order for it to be a proportional table, it is going to have to be equal all the way down for all the different options. So right here, even though these two are 0.5, this one's only 0.4, so since these are not all the same, it is not proportional. In the next video, you're going to see some examples, and hopefully this will all kind of make sense. Hopefully you enjoyed this video. See you later.